Hey guys, we're going to do notes for Packet 5, Modeling and Quadratics. All right, so make sure you have your name on here when you turn in the packet. And we took notes on the second page, third, and not the fourth. So we're going to take notes on these two sheets, and then the rest of our packet will be complete. Okay, so let's take a look at a few questions here on the front. It says a coffee variety, Arabica, yields about 750 kilograms of coffee beans per hectare, while Robusta yields about 1,200 kilograms per hectare. Suppose that the plantation has alpha hectare of Arabia and R hectare of Robusta. Write an equation relating to each. Okay, so if the plantation yields 1,000,000 kilograms of coffee, then this would be alpha hectares, right? And we'd multiply against it, this first one, 750 kilogram per 1 hectare. So what happens here is that hectares cancel, right? And leaves our answer in kilograms. So we know that, I'll just put this 1A, we know that since our units cancel, we know that 750 times alpha has to equal 1,000,000 kilograms, okay? So then, in the same way, we would know that this would be the same. So if I came in here and then instead said it was 1,200 per 1 hectare, then I would know that it would be 12,000 times this Greek letter R, rho, is equal to 1,000,000 kilograms. Okay, so A is done. Now it says on August 14th, that's interesting, that's my birthday. On August 14th, the world market price of coffee was $1.42 per kilogram of Arabica. So this is the first kind. And 73 cents per kilogram of Robusta. Write an equation relating to alpha and rho if the plantation produces $1,000,000 worth of coffee. Okay, so we need an answer that is $1,000,000, right? We need an answer in the unit dollars. So this helps us decide, do we multiply or do we divide? So in our first brand, we have $1.42 per kilogram. So now we can multiply by kilograms, which would be 750 divided by alpha, right? This would give our answer in dollars because this answer was in kilograms, and kilograms would cancel. So we can say that would have to equal, write an equation relating if the plantation produces $1,000,000 worth. Okay, so $1,000,000, right, times we know it's, so I'm actually going to divide $1.42 per kilogram. And then we know that this is 750 alpha is listed in kilograms. So notice what happens here. Kilograms cancel, and we have an equation relating to alpha. Here's my alpha here. All right, my next equation would be the same, $1,000,000. But I now use the other one, right? So I have 73 cents per kilogram, and then I know that 1,000,000 kilograms, 1,000,000 kilograms is equal to 2,000 rho, right? So kilograms cancel, dollars cancel, and we have our equation, right? And believe it or not, that's all they want. They want us to kind of put together an equation, and you probably wouldn't have to type this in. It would be multiple choice, and you'd pick one that they would accept. Okay, so this is looking pretty good. Now let's try out what would be a question that would look like a multiple choice. So we kind of answered an open-ended question, but it'd probably be more likely that they ask a multiple choice. So let's read on. It says a student council is selling rolls of gift wrap and ribbon for the holiday season. The council charges $10 a roll for gift wrap and $3.50 for a roll of ribbon. Okay, so $10 gift wrap, $3.50 ribbon. So we see these numbers show up here, gift wrap and ribbon. The student council will receive profit as 60% of the total sales. The student council has a fundraising goal of at least $1,500. Okay, so if they have the goal of making the student council will receive as profits only 60% of the sale, then whatever they make, this is what they make. When you multiply it times 60%, we need that number to be 1,500, right? So let's do a little algebra. We're going to divide by 60 on both sides. So we need to make in our fundraiser 1,500 divided by 0.16. 1,500 divided by 0.6. Okay, so we need to make 2,500. So this makes sense that some of these numbers, we need to make that. All right, now most people are okay making more than that. So this is how much we make. Or maybe not, that's how much we sell. So we could think, we've got to figure out, is this how much it's costing us or how much it's making? So let's read on. It says the student council has a fundraising goal of at least 1,500. Let G be the number of rolls of gift wrap sold. Let R equal the number of ribbons sold. Which inequality represents the fundraising goal? Okay, so we know it's okay if you sell more. So if this is what we sell, we need to sell equal to or more than $2,500 worth of stuff. So if this is $3,000 worth of stuff, it's okay if it's more. So I'm definitely settling on D. Okay, so we answered a couple questions on this learning goal. Now let's find one on this other learning goal. So the other learning goal talks about when f of x and g of s intersect. Okay, so when we look onto this question, this is a classic question, we have one quadratic and then we have one linear. So they list the quadratic as this function, x squared minus 4, and they list the linear as x plus 2. Now they say, explain how we find the solution. So we have a couple ways of finding it. One is from graphing. So we see that this first point is at -2, 0. And we also see that it's at 3, 5. So we say to ourselves, well, what would be another way to solve it? Well, this is equal to y, right? And this is also equal to y. So since y is equal to this and y is equal to that, we should be able to put one equal to the other. Okay, so now let's get everything by its over here by the other stuff, right? Right? And so let's move this over here. Okay. Now, that's where we're at. We need to factor this. This is in standard form. So let's say to ourselves, what adds to get -1, that's what's here, -1, and multiplies to get -6. So I think that would be, what is that? 2 times -3 would add to get, so So 2 minus 3 would be -1. That works. And 2 times -3 is -6. That works. Okay, so we can write x plus 2, x minus 3. And we notice inside are liars. That's lying. So why did we get -2? -2. Why did we get 3? 3 here. We know that is where they intersect. How would we get the other numbers? So we notice these numbers are -2, and this number for x is 3. How could we have gotten that with algebra? We can plug them in. So when we plug in 3, 3 plus 2 is 5. That's why we got 5. When we plug in 3, we get 3 squared minus 4. 9 minus 4 is 5. Well, that tells you that one. So let's plug in -2. When we plug in -2 here, we get -2 times -2 is 4, and 4 minus 4 is 0. So that's why we got 0. How did we get our answer? It seemed like it took a while, didn't it? But actually, we got the answer right in the beginning. First, we said use the graph to find the solutions, and we did. Why did we keep going? Well, because they said explain how we found them. All right, we're going to do one more. Oh, there's so many good ones. I think maybe this one, 5, because it's multiple choice. Okay, so it says if x equals 2, so let's figure out what x is 2. So this is an x and y axis. This is y and x. X equal 2 would be parallel to y axis over here. This is where the values are for x equal -2. Okay, so this is x equal -2. There it is. Now it says if that's a solution to the equation f of x equals g of x, which of these statements must be true? So that means these two must touch at this line, has to. Then the graph of f and g intersect each other at, ooh, I like this. Okay, this seems to be saying, so I don't know where this one is. You know, maybe it's going like this, and I don't know where that one is, but they definitely meet here. That's kind of like what that one's saying. The graph of f and g intersect each other at +2. That one doesn't make sense at all. The graph of f and g intersect at the x-axis. No. So what does that mean? That means we don't know where this is. This is the x-axis. All we know is they intersect at this location. Okay, so I definitely feel confident that we picked the right answer. And there you have it, guys. Thanks for joining us. See you next time.